This video will cover the topics in section 1.3 of linear functions. The goal of this video is to define linear functions, cover slope characteristics, and calculating rate of change, going over the forms of linear functions, the graphical interpretations and characteristics of a linear equation. A linear function is a function whose graph produces a line. Linear functions can always be written in the form y equals mx plus b, or function notation using f of x equals mx plus b. B is the initial or starting value of the function. That's when the input is 0 or x equals 0. And m is a constant rate of change of the function. This is a key characteristic of a linear function in that it is a constant rate of change. This form, y equals mx plus b, is called the slope-intercept form of a line. Oftentimes you may see the form f of x equals b plus mx because it corresponds to the way we tend to speak. And so the way we would interpret this is the output starts at b, the initial value, and increases at a rate of m, if m is positive. M is the constant rate of change of the function, which we define as the slope of a linear function. The slope determines if the function is an increasing function or a decreasing function. If m is positive, then the function is going to be increasing, and if m is negative, it's going to be decreasing. If m equals 0, the rate of change is 0, and the function is just a horizontal line passing through the point that's the y-intercept, 0, comma b. It'll be neither increasing nor decreasing. If you want to calculate the rate of change of any function, not just lines, you'll need to have 2 points to do so. So given two values for the input, x1 and x2, and their corresponding output values, y1 and y2, which oftentimes are going to be written as a set of points, if we wish to find a linear function that contains both points, we can calculate the rate of change as the change in the output, or delta y, over the change in the input, or delta x. So y2 minus y1 over x2 minus x1. Rate of change of a linear function is called the slope of the line, and it is constant. Let's do an example. A town's population has been growing linearly. In 2005, the population was 69,000, and the population has been growing by 2,500 people each year. We want to write an equation P of t, so that's the population as a function of time, for the population t years after 2005. So 2005 will essentially be year 0. And if it's growing by 2,500, that tells us that the slope of this function is going to be positive 2,500. And so P of t is going to have the form of its initial value b plus the slope times the number of years since 2005. So our initial value is 69,000. And so our function, the population as a function of time t, will be 69,000 plus 2,500 t. Another form to write the equation is the point slope form. Oftentimes this is easier to use if we don't know the initial value. An equation for the line passing through the point x1, y1 that has a slope m can be written as y minus y1 equals m times the quantity x minus x1. This is known as point slope form. It's a little easier to write if you know a point and the slope, but it requires a bit of work to rewrite into slope intercept form and requires memorizing another formula. And so if you do have 2 points where one of them is not the y-intercept, this would be the most ideal form to use to find the equation of the line. Graphically, in the equation f of x equals b plus mx, b is the vertical intercept, that's the y-intercept of the graph, and tells us that we can start our graph at the point 0, comma b. So that's when x equals 0 and the y value is b. M is the slope of the line and tells us how far to rise and run to get to the next point, and we'll typically always run to the right as you rise. So we want to sketch the graph of the equation f of x equals negative 1/3 x plus 2. And so the starting point is at 0, 2, because that's the b value, and the slope of this line is negative 1/3. So we'll start at the point 0, comma 2, and we'll go down 1, and to the right 3. And that's where our next point will exist. And we could do this again. Up 1 and back 3 to get another point on the line. And here's our line f of x equals negative 1/3 x plus 2. So we have a decreasing function because the slope is negative. If we want to find the intersection of lines, the graphs of two lines will intersect at the point that satisfies both equations. To find this point when the equations are given as functions, we can solve for an input value, or the x value, such that the two functions are equal. In other words, we can set the formulas for the lines equal and solve for that input that satisfies the equation. Since we are dealing in business calculus, we want to oftentimes use this in economics. And it tells us that in a free market, the price for an item is related to the quantity that it produces, will supply, and the quantity that consumers will demand. Increases in prices will decrease demand, while supply tends to increase with prices. Sometimes supply and demand are modeled with linear functions, and we want to know when will supply equal demand. Oftentimes, we want to know when does supply above demand and vice versa. The next video will cover exponents.